3I Atlas was first flagged by the Atlas survey in mid-2025 and quickly identified as an interstellar visitor, meaning its path through the solar system is hyperbolic, not a looping orbit. It showed up on instruments in July, gathered attention as it sped inward, and reached perihelion, its closest approach to the Sun, around October 30th, 2025. Observers tracked its brightness and motion from multiple sites, and every major clearinghouse, MPC, NASA summaries, treated it as a scientifically interesting but not Earth-threatening interstellar object. Those are the facts almost everyone agrees on: discovery, dates, and basic orbit. But while that timeline is tidy, the measurements that followed are anything but, and that's where the story gets complicated. Once the discovery dust settled, scientists began noticing something that didn't fit the usual Comet checklist. Spectrographic readings hinted at a metallic composition far richer in nickel than typical comets, but with surprisingly little iron. That ratio raised eyebrows. It's the kind of mixture engineers use in high-temperature alloys, not something naturally forged in deep space. Then came the light curve anomalies, brightness that fluctuated in sharp, irregular bursts instead of the smooth fade and flare pattern comets normally show. Even stranger, the so-called anti-tail, a jet of material apparently streaming toward the Sun rather than away from it, suggested that particles might be behaving under some unusual forces. Instruments confirmed it wasn't an optical trick, and that left researchers debating everything from magnetic field interactions to yet unexplained particle dynamics. Each test produced more puzzles than answers, and the combination of nickel spikes, odd light scattering, and a backward jet made 3I Atlas stand out as a comet that didn't seem to have read the rulebook. But the deeper astronomers looked, the more bizarre the statistical picture became, and that's where the next chapter of this mystery begins. When scientists tried to crunch the numbers on 3I Atlas, the odds started looking suspiciously low for something natural. Its trajectory entered our solar system within just a few degrees of the ecliptic plane, the same flat path along which planets orbit the Sun. That might sound normal, but for an interstellar object it's rare. The chances of a random visitor aligning that closely are roughly 2%. Then there's its mass and velocity, far greater than earlier interstellar objects like Oumuamua or Borisov, yet somehow moving faster. The probability of those size and speed values coinciding by chance? Less than 0.1%. One anomaly could be coincidence. A dozen start looking like a pattern. Researchers began calling 3I Atlas a statistical nightmare, because every property seemed to strain what's considered cosmically typical. What truly unsettled experts was that each new observation layered another improbable detail. A weak water signature here, an unusual polarization pattern there, tiny clues that stacked up into something almost too improbable to dismiss as random. And as one astronomer put it, either we're witnessing a once-in-a-billion natural fluke, or something we don't yet understand is at play. Then came the whispers of a potential course change, a claim that split the community down the middle. Independent observers online began posting coordinates that didn't quite match NASA's predicted path for 3I Atlas. The discrepancy sounded small, mere arc minutes on the sky, but at that distance it would translate to nearly 1 million kilometers of lateral shift. That's the kind of deviation you might expect if an object were under controlled propulsion, not gravity alone. Mainstream astronomers were quick to caution against jumping to conclusions. Measurement errors, calibration issues, or even outgassing jets could nudge a comet's trajectory slightly off track. But the idea of deliberate movement caught fire online, especially when data seemed to show the object drifting farther off course with each new reading. If true, it would mean 3I Atlas wasn't just tumbling through space, it was steering. Of course, extraordinary claims need extraordinary proof. At the time of those reports, no observatory had verified the supposed shift. Still, the story gained traction because of its implications. If the deviation was real, we'd be witnessing the first interstellar object ever observed performing a maneuver. Adding to the intrigue, NASA's silence became part of the mystery. When 3I Atlas passed behind the Sun, Mars-based orbiters were in perfect position to capture high-resolution images, but none were released to the public. These probes routinely image asteroids, comets, and even passing debris, so why the blackout now? Some suggested it was just a matter of data backlog or technical delays, while others speculated the images might reveal something too perplexing to publish before careful review. At the same time, the International Asteroid Warning Network launched a rare, globally coordinated campaign to track 3I Atlas as it re-emerged. Hundreds of telescopes would aim at the same patch of sky, recording every faint flicker of motion. That kind of mobilization had never been done for a comet before, not even for Oumuamua, so as 3I Atlas disappeared behind the sun, the world waited. Would it come out exactly where predictions placed it, or somewhere else entirely? The next set of observations would either quiet the rumours or ignite one of the biggest astronomical debates in history. By early November 2025, astronomers around the world were on alert. 3I Atlas was about to emerge from behind the sun, the moment when speculation would either collapse or explode. If the comet reappeared exactly where NASA's models predicted, then all the online buzz about course changes and hidden propulsion would fade into the background noise of the internet. But if it came out off course, even slightly, it would force an uncomfortable question. How could something so massive drift that far without a measurable cause? The International Asteroid Warning Network's 2-month observation campaign was already in motion, mobilizing research teams from Chile, Hawaii, Australia, and Japan. Dozens of observatories prepared for synchronized data logging, a kind of global space watch in real time. Never before had the astronomy community treated a single interstellar object like a live experiment. For some, it was exhilarating. For others, it felt like holding their breath for the verdict on one of the strangest mysteries in recent history. Whatever the results, the re-emergence of 3I Atlas would be decisive. If the comet appeared where expected, the story would end as a fascinating but natural anomaly. If not, humanity would be forced to rethink what natural even means. Even before any final data came in, the implications of 3 Atlas had already rippled through the scientific community. Harvard astrophysicist Avi Loeb, known for challenging conventional thinking, had recently submitted a paper urging international collaboration on interstellar objects that might display signs of artificial origin. His argument was simple. Even if the odds of intelligent design are small, the impact of such a discovery would be enormous. What he called a black swan event. That idea resonated with many astronomers who saw 3I Atlas as a wake-up call. It reminded them how limited our experience with interstellar matter truly is. We've only observed a handful of these visitors, and each one has shattered expectations. From Oumuamua's pancake shape to Borisov's comet-like structure, and now Atlas with its bizarre chemical makeup. The universe keeps sending us curveballs. Maybe the lesson isn't that something artificial is visiting us, but that nature is far more inventive than we give it credit for. Still, the coincidences piled high enough that even skeptics admitted, this object is worth watching closely. When something defies that many odds, curiosity isn't conspiracy, it's good science. When the first re-emergence data finally arrived, the tension broke. 3 Atlas appeared close to its projected coordinates, within the margins of natural variability. No evidence of a deliberate maneuver, no dramatic shift in direction. For many scientists, that settled the debate, a bizarre but natural comet. But others pointed out that the same anomalies remained. The nickel-heavy composition, the weak water signature, the anti-tail, and the statistical oddities that still refuse simple explanation. What 3I Atlas ultimately revealed wasn't proof of alien engineering, but a deeper truth about human curiosity. Every time we encounter something that bends our expectations, we project meaning onto it, sometimes rational, sometimes fantastical. Yet this drive to question, to look again, is exactly what pushes science forward. So maybe 3I Atlas isn't a Trojan horse from another civilization. Maybe it's a mirror, reflecting how eager we are to find patterns and how reluctant we are to accept mystery. Whatever it is, one thing's certain. It's made us look up again, question harder, and remember that even in a universe full of answers, The best stories always begin with a question.